Hi all, in this lab, let us understand how to implement one more integration pattern called scatter gather. Okay, so this is part of the decoupled architectural series. Now let's understand how to implement this architecture. Okay, so we have API gateway which is front-ending the clients, and we have one Lambda function which is processing the request from the clients. And the request is for a given quotation. Okay, and for example, if the customer wants to know the fare from destination A, I mean from A to B, and how much it will cost, now that request is processed by the Lambda function, and it sends the request to an SNS topic. From the SNS topic, with the pub sub architecture, many subscribers were added to the SNS topic. Okay, so in this case, there are two Lambda functions which are receiving this request. So these Lambda functions will process the request and provides the code for the given RFQ and sends the response back to the SQS queue. Okay. Now here the SQS queue is again sending the response to a Lambda, which in turn stores the results into DynamoDB. Okay. Now initially the request is coming to Lambda and which is now sending it to all the subscribers who are processing, and then they will be responding with the respective code, and that code has to be assembled back into a database, so that if the client wants to access the codes, then there is one more Lambda function called query for the code. So this will read from the DynamoDB database and sends the request back to the clients. So this is an end-to-end flow. Okay, so the scatter gather is basically now the initial request we are basically scattering to multiple providers who are providing the service. Now we are gathering the responses and providing that back to the client. Okay, so that's how the API gateway is providing two functionality. One is request for the code, the second one is query for the code. Okay, now let's go to the source code and see how to implement this entire architecture using Terraform. Okay, hi all, in this lab let us understand how to implement scatter gather, one of the integration pattern between the microservices. Okay, so let's go to the source code. Let's start with main.tf. So here, let us understand how to use a different IAM role in a different account. So here I'm assuming this role from this account, okay, and this IAM role. So that means any AWS resource that we are creating through this Terraform scripts will be created in this account, okay. Now let's first go to the API gateway, which is front-ending the client request, okay. So we have one API request, which is a REST-based API, and the type of the endpoint is called Edge. Okay. Now the method, the resource that we are creating is basically submit instant write RFQ. So this is one of the resource that we are creating it, and one more resource we are creating is a query instant write RFQ. So we are submitting a request for quotation and we are querying it. So once you submit a request for quotation, then there are some components, some service providers will provide the response to the RFQ, and there is one more call to query that. Okay, and when we query, we also need to provide the RFQ ID number, okay, as a parameter, and the method that we are providing to the first API is basically the post method. Okay, and the method that we are using for the second one is the get method, because get method is used to get the response for the quotation, and one of the parameters that we have to provide is in the path, and the name of the parameter is called ID. Okay, so this is how the configuration looks like. Now the integration method is AWS proxy, and we are using a Lambda function, and the type of the integration method is post. Okay, please note that for both integration methods the HTTP method is post. Okay, so we are creating one stage called prod. Okay, and these are the rest of the dependent resources. So if any one of the resources changes, the deployment will be done again. Okay, so there are few IAM permissions with respect to the CloudWatch logs that is required for the API gateway. And if you go to DynamoDB, we are creating one DynamoDB table with billing mode as a paper request, and one key which is ID and its subtype string. Okay, Now, when the request comes to API gateway, it will go to the Lambda. And so we have a couple of Lambda functions here. So one of the functions is called query for quote service. Okay. So this is the first function which gets executed when a client sends a request for the RFQ. Okay. Now this particular one is triggered by API gateway, and we have to provide some environment variables to this Lambda because it has to push a message to the SNS topic and also update the DynamoDB database with the request. And one more Lambda function which is unicorn message management resource one. This provides a quotation, okay, for the incoming request. So here we are providing SNS topic as the trigger point because SNS will push the message to this Lambda. Similarly, there is one more Lambda function which also does the same thing. Will submit a code for the RFQ and trigger point is same. And there is one more Lambda function which is course response service. Once this above Lambda functions provides the response, that is the quotation for the RFQ, then this Lambda function gets triggered and store the messages into the database. Okay. So the way it works is the quotation is sent to the SQS queue and this is triggered by um, this triggers this Lambda function. This Lambda function will go and store the response into the DynamoDB database. Okay, and these are the IAM permissions required. Now, one more function we need to understand is query for the code service. So once you send a request for the quotation, then you send one more request for the response. So this is a query for the code service. Okay, and it has to fetch the data from the DynamoDB. Okay. Let us go to sns.tf. So we have one simple topic which is request for code topic, and there are two um, subscribers for this. Both of them are Lambda, and these Lambda functions will provide the quotation for the RFQ. Okay, and this is very simple. Now coming to the SQS queue, we have one queue, and this queue is basically used to put the messages from the quotation. The quotation is kept inside this SQS queue by those respective Lambda functions. Okay, and these messages will be sent to another Lambda which will store in the DynamoDB database. Okay, now let us go ahead and deploy this and test end to end how it looks like. So Terraform plan is done. So let us give it some time. So Terraform plan is done. Now Terraform auto apply. So Terraform apply is completed. So here you see the output URLs. This is the query URL that we will be using to test the functionality. Okay, let's go to the console. So let's first go to the API gateway. So this is the API that we have created, which is a REST API. And here there are two resources. One is the slash query instant ride RFQ, and within that we have to provide one parameter called ID. Then there is a function called get to get the code. Okay, so this is not having any authorization, and it is sending the request to Lambda. So using the AWS proxy as the integration method. So Lambda is the one which is getting triggered to process the request. Okay, so query for code service, let us see what it does. It will simply now let us understand, not this. So we have to look for some other Lambda. This will come back to that later. Let's first look at the submit instant ride RFQ. Okay, first we have to send a request. Okay, so the request is sent to this Lambda, request for quotation. Okay, So here API gateway is the one which is triggering this Lambda request for quote. So here it is basically sending a message to SNS topic and also updating DynamoDB with the request. So it's a simple function. So once this is done, then there will be, once the SNS topics are updated with a message, then the message will be sent to the respective lambdas who will process this request. Okay. So let us go to SNS topic, and we have one topic here, and there are two subscriptions for this topic, and both of them are lambda functions. Okay. Now one of the function is called unicorn management resource 1, another is the unicorn management resource 2. Okay. So if you go to lambda functions and look at the code for these functions, so you see that it basically does a calculation of a quotation. So it simply gets a random value and sends this random value as a quotation for this RFQ. Okay, and it's sending it to a queue. Okay, SQS queue. Now this SQS queue is configured as a part of the Lambda environment variable. So this is where we are configuring. Similarly, if you look at the other function which is also doing the same thing, random value it is sending as a quotation to the RFQ to the SQS queue. Okay. Now once the SQS queue is sent the message, it will trigger one more lambda. Okay, let's first go to SQS queue. Okay. So okay, let's go to SQS queue first. We'll come back to DynamoDB later. So this is a queue where the quotations will be sent, and this triggers one more lambda, and this lambda is called quotes response service. Now if I go to the quotes response service, this is where it is triggered by SQS queue, and it will simply update the response to DynamoDB. Okay. Now finally, when the users calls the query instant write RFQ and with the RFQ ID, then that data is coming from this lambda basically. Okay. There is one more lambda called query for code service. So this lambda will go to the DynamoDB and send the list of quotations. Okay. Now let us go to the console and see how to test this functionality end to end. Okay. So here let us get the URL. Okay. From the Terraform output. This is a URL where we will be submitting the request to the API gateway, and this is the input data that we are sending it from Frankfurt to Las Vegas. If you want to know how much it will cost, right? This is a simple query. So let us say we will send this request. The RFQ ID is this. So this ID is important because using this ID only we have to send the next request. Okay. So I'll just copy paste this ID. So the response that we got is quote is 6. So it is coming from Unicorn Management Resource 2. So one of the two components who are providing the quotations. So one of them is resource 2, Unicorn Management Resource 2, and it is providing a quote of 6. Okay. Now let's understand how the entire flow works. Let's go to the console again. Let's first go to the main function request for quote. Okay. So let's go to the monitor section and see the CloudWatch logs. Let us follow this request, how it happens. The request is coming here, and so this is where you will see. So we are getting this particular request coming from the clients. Okay. And from there it's going to the SNS topic, and from the SNS topic it is going to other lambdas. Okay. So this is one of the lambda which is doing the processing of the quotation, I mean RFQ. So the RFQ is processed, and a quotation is sent using a random value like we discussed earlier. If I look at the logs for this, so you can see that so this is the received event, okay, and this is the SQS message. So this is the code that we saw in the output, right? Code. Now this is sent to the SQS queue, and this is read by one more Lambda, okay, a request for codes response service, okay, and this is reading from SQS queue, right? Because SQS queue is containing the messages, and this Lambda is reading from that and updating that into the DynamoDB. So if you look at the logs, so this is the event that it has received and it is processed. So finally, the query for code service is the one which sends the response back to the clients. So this is where you will see it is reading from the database and providing that to the users, the requested for the RFQ, the provided codes, it is basically sending it. Okay. Okay. So this is how the end-to-end flow is working, right? So we have two functions, two API or two resources within a given REST API. So one of the API is to provide a request, the other API is to get the response to that request RFQ. Okay, and we have parameterized this value ID in the get method, and both of them are using Lambda as an integration. Okay, so this is how we can test the scatter and gather functionality.